Cold water storage systems. Storage systems and the water regulations. Schedule 2, paragraph 16 of the water regulations tells us that a storage system supplying low pressure cold water to sanitary appliances or feeding a hot water storage system should be capable of supplying wholesome water. Various protection measures must therefore be included in the design of the system to ensure that the water supply does not become contaminated or unwholesome. To comply with the water regulations, systems must be fitted with an effective inlet control device to maintain the correct water level, i.e. a flow operated valve, FOV. Be fitted with service valves on inlet and outlet pipework connections to allow for maintenance and repair activities. Be fitted with screened warning overflow pipes. Be covered with a rigid closed fitting lid, which is not airtight but excludes light and insects. Be insulated against freezing or undue warming. Be installed so that the risk of contamination is minimized. Be arranged so that water can circulate, preventing stagnation. Be supported to avoid distortion or damage, which could lead to leaks. Be accessible for maintenance and cleaning. Temperature of stored cold water should not exceed 20 C. Systems must be manufactured and installed to these requirements if the problems of contamination are to be avoided. In the past, when systems were fitted with unscreened overflows and poorly fitting lids, insects and small mammals could easily gain access to the water that the systems contained. Some insects, like mosquito larvae, need water to complete their life cycle, and these must be excluded at all costs. Correct installation will eliminate the problems mentioned, especially when avoiding the problem of stagnation of water. Types of system. Storage system. This is designed to hold a supply of cold water to feed appliances fitted to the system. Storage systems are used on indirect cold water systems and supply cold water only. Feed system. This can be identical to the storage system. However, it only holds the water required to supply the hot water storage vessel. In other words, it supplies cold water via the cold feed pipe to a hot water. Damn it! Via cold feed pipe to a hot water storage system. Combined storage and feed system. This is a combination of the previous two. It is used on an indirect system of cold water where only the drinking supply is taken directly from the main and the rest of the water is supplied from a system. It stores water for the domestic hot water system and the indirect system of the cold water to the appliances, wash hand basin, bath, WC, washing machine, etc. Feed and expansion system. Used to feed a vented central heating system and allows expansion of water into the system when the system is hot. WC and automatic urinal flushing systems. Used to clear the contents of a WC or urinal. The water they contain is not considered wholesome. They will be covered in more detail later on. Capacities of systems. BS 6700, replaced by BSEN 806, recommends the following capacities for houses. Dwelling type small house. System capacity cold water only would be 100 to 150 litres. In a small house and hot and cold water, 230 litres minimum. In the same small house, hot water only, at least the capacity of the hot water storage vessel. In a large house, 100 litres per bedroom. The size of cold water system installed will depend on what it is feeding. For systems that only support cold water to baths, wash basins and WCs, then 100 to 150 litres of stored water is sufficient. If the system is supplying cold water to a water storage vessel, then the system should have at least the same amount of storage as the hot water storage vessel. If the system is supplying cold water for both hot and cold supplies, then the minimum recommended storage capacity of the cistern should be at least 230 litres. Kitchen sinks cannot be supplied from a protected cistern. The supply must come direct from the mains cold water supply. General installation requirements for cisterns. Water is heavy. At 4 degrees Celsius, it weighs 1 kilogram per litre. So 230 litres will weigh 230 kilograms. Almost a quarter of a ton. A cistern full of water will therefore need adequate support, especially if placed in a roof space. Normal practice would be to try to place the cistern over a load-bearing supporting wall. But if this is not possible, then the platform must be big enough to support the weight of the cistern and the water it contains by spreading the load across the roof joists. The platform that the cistern sits on should be covered with 21mm tongued and grooved boarding or moisture-resistant plywood. The platform should be at least as big as the base area of the cistern and if possible 150mm larger all the way around. Access to the cistern once it has been installed is vital for cleaning, inspection and maintenance. The minimum access allowance will depend on the size of the cistern. For cisterns of less than 1,000 litres, 350mm must be allowed to permit access to the FOV for removal and replacement. Inlet requirements for storage cisterns. The inlet requirements state that all cisterns will be fitted with an adjustable water inlet control device. These devices are usually flow-operated valves that must conform to British Standard 1212/1990. These will be covered in detail later on. Outlet requirements for storage cisterns. Outlets from a cistern include indirect cold water distribution pipes and cold feed pipes to hot water storage systems. Connection of the cold feed pipe and cold water distribution pipe to the cistern should preferably be positioned at the base of the cistern. Although positioning these connections on the side of the cistern is also acceptable, the distance between the cold feed and the cold distribution pipe work should not be less than 25mm, with the cold feed pipe higher than the cold distribution pipe. The cold feed for the hot water system should always be higher than the cold distribution pipe connection. This is so that, in the event of mains cold water failure, the hot water will run out first, which will prevent any potential scalding situation if any mixing valves, showers, bath mixers or monoblock wash basin mixers are installed on the system. Prevention of stagnation. Pipework connections to cisterns should be positioned so as to avoid stagnation by ensuring an even flow of water through the cistern. A single outlet should be positioned on the opposite side to the FOV. Where 2 connections are required, they should be arranged so that the connection with the greatest water usage is positioned furthest away from the FOV. Warning and overflow pipes. A warning pipe is smaller in diameter than an overflow pipe. It acts as a warning that the FOV has developed a problem and the cistern is about to overflow. It is installed in a lower position on the cistern than the overflow pipe. An overflow pipe is larger in diameter than the incoming water supply and must be able to cope with the flow of water in the event of complete FOV failure. This is to ensure that the FOV does not become completely submerged in water at any time during critical velocity when the water is running at full bore. Warning and overflow pipe should be installed so that the water is taken to the outside of the property and positioned in a conspicuous location. The requirements for warning and overflow pipes differ depending on the volume of the cistern. Cisterns below 1,000 litres capacity do not require separate warning and overflow pipes. A single combined warning overflow pipe only is required. The bottom of the combined warning and overflow pipe should be a minimum of 25 millimeters above the water level of the cistern. Linking cisterns. On occasion, to provide large quantities of stored water or due to space restrictions, 2 or more cold water storage cisterns may need to be linked. If the cisterns are not interconnected correctly, then stagnation of the water may occur, and this could lead to the growth of Legionella bacteria, Legionnaire's disease. To avoid Legionella bacteria, cisterns should be small enough to ensure rapid turnover of water to prevent stagnation, have inlet and outlet connections at opposite ends, be regularly inspected and maintained in a clean condition, conform to the requirements of the water regulations. In practice, cisterns should be interconnected to allow free movement of water from one cistern to the other. They should be connected at the bottom and the middle so that the water passes evenly through them. The primary outlet connection should be made on the opposite cistern to the FOV to encourage water movement, with the secondary connection made on the cistern with the FOV installed. The overflow warning pipe should be fitted onto the same cistern as the FOV. Both cisterns must be of the same size and capacity. When connecting 2 or more cisterns together, care should be taken to ensure that the water movement is regular and even across all cisterns. In this situation, it is a good idea to install FOVs on all cisterns with appropriate service valves as detailed in the water regulations. Every flow operated valve must have a service valve fitted as close as reasonably practical. Wherever an FOV is fitted, an overflow warning pipe must accompany it. These must terminate in a conspicuous, visible position outside the building. On no account should they be coupled together. There should be service gate valves positioned to allow for isolation and maintenance of the cisterns without interrupting the supply. The diagram shows how any 2 of the 4 cisterns can be decommissioned, leaving 2 in operation. This ensures continuation of supply. Materials for cisterns. Almost all new installations use cisterns made from plastics such as polyethylene, polypropylene, and glass reinforced plastic, GRP. Most cisterns manufactured today are made from polypropylene because this allows lightweight construction, strength, hygiene, resistance to corrosion, flexibility. Cisterns pass easily through roof space openings. Holes for pipe connection should be cut out using a hole saw. A 17mm hole saw should be used for half-inch thread connections such as FOVs, and a 25mm hole saw for 3/4 in thread connections such as tank connectors. The joint between the cistern's wall and the fittings should be made using plastic washers known as poly washers. On no account must any oil-based jointing compounds be used, as they can break down the plastic and provide a culture where microbiological growth such as Legionella and pneumophila, Legionnaire's disease, can occur. Galvanized steel cisterns were used for many years, but these were notorious for corrosion. Galvanized steel cisterns are still manufactured and can still be used, provided the inside of the cistern is protected by the use of a special paint, which is registered in the water fittings and materials directory as safe to use with wholesome water. That will be enough today on cisterns, cold water storage cisterns to be exact. And you can get all of this in the City and Guilds textbook, Level 2 in Plumbing Studies 6035 by Michael B. Masgray and Emon Wilson. Thank you ever so much for listening and enjoy plumbing. Have a great day.